Saxon Algebra 1/2, Lesson 45. Greetings, students. Welcome to the last week before the midterm. We're going to cover these two lessons right now. Well, you know, if you're going to watch them together, I'm going to record them together, and then I'm going to give you those two. Woohoo! Then we'll be ready to rest our brains by taking a test. Won't that be fun? It's going to be great. Lesson 45 is about volume. Now, we've learned how to measure length, and that is one-dimensional. And we've learned how to measure area, and that is two-dimensional. The best example of length is a piece of string. The best representation of area is a piece of cloth or paper. I like to imagine cloth because I'm sure you have gone to a fabric store at some point in your life and they open up the bolts and they cut it. I find that a very interesting and appealing process. Length is also good for chain. Have you ever gone to Home Depot and bought chain when it's on the long spools and you get to unravel it out? It's really fun. Today we're going to add to this volume, which is three-dimensional. And that makes these problems fun because you get to draw cool things like this. And my favorite example of these is imagining that we're pouring some sort of liquid into these, milk or water. They're square. You don't really find very many perfectly square milk cartons, but we'll kind of use that concept that we're pouring liquid into something and trying to figure out how much space it takes up as an example. We're going to start with some simple shapes, and it's going to get crazier, but I'm going to give you an all-purpose formula that will always work for volumes. The volume of any object is equal to the area of the base of the object times the height. Now, we're going to be finding the volume of a lot of really weird shaped things, but this formula will always work. And we'll see more about that as we go. There are there's only two problems so far that we're going to do. The first one, and I want to show you how John draws out these pictures. So let me just put the book down so you can see. We're looking here. The rectangle, look, there's John's version of the formula. Ta-da! I like mine better. The rectangle shown is a base of a right solid whose sides are 4 centimeters tall. Dimensions are in centimeters. Find the volume. Okay, let me tell you what he's talking about. He's saying this is the three-dimensional object, as you can tell, because it looks three-dimensional. And he's telling us it's 4 centimeters tall. That would be this dimension, okay? But what he's doing for us is he's saying, okay, the base is down here, right? Let's pick it up and look at it. That is a picture of the base. That is what's underneath here. So when we're trying to apply this formula, area of the base, John gives us a map of the area of the base. We find that first, and then we just multiply it by the height, and we've got the whole thing. All right? So let's do that. I'm going to not draw the three-dimensional object because that doesn't really help us. But what I'm drawing is a map of the base. And we can see it's a rectangle. Look at what a perfect rectangle that is, right? Kidding. And John has numbers on it. He has a 2 over there. His 6 is on the bottom. I wrote down there. You can't really see it. But he wrote a 6 up here and a 2 there. And we know that for rectangles, the area of the rectangle is length times width. So it would be 2 times 6, which is 12. That's the area of the base, okay? So I'm going to write area. I'm going to substitute it like that, AB. The area of the base equals 2 times 6, which is 12. The height, John told us, is 4. So then we're going to multiply that by 4. And our final answer will be 48. He told us it was centimeters. Volume is a three-dimensional measure, so it's always centimeters cubed. Cool, right? And so easy, you guys. All right, so that was a shape that was just like a box, right? It just had a simple rectangle. What if our shapes start to look just a little bit more complicated than that? And let me show you the picture in the book again. This one looks a little different if we just look at that, right? We can see it's got straight sides, which is good. We're never going to have to deal with things that have, we're going to deal with curved sides, but we're not going to deal with sides that like tip in. They'll always be perfectly straight like this. This is what is meant by the phrase a right solid. It means it's a three-dimensional object with straight sides. This line meets this line at a right angle. That is good news. Whenever you see this right solid, don't let that put you off. I used to, when I was starting this, I think, ugh, that sounds scary and hard. No, that's your friend. That means it's got straight lines and it's nice and even. You don't have to do any weird calculating for that. Okay, so what this means is this is the three-dimensional. It's like one of those boxes at IKEA. I don't know if you guys have shopped at IKEA much, but a lot of their boxes have really weird shapes because they're all about packing efficiencies. So they have some weird shaped boxes, and I always think of IKEA with these. If we pick up this shape and look at the bottom of it, that's the map of the base. So what we're going to do is we're going to find the area of this and multiply it by the height. We see it says right there 6 feet tall. All right, we're good to go. I'm not going to draw the three-dimensional object, but I am going to draw the base. That is the most important part. Now, I can see this isn't just a simple rectangle like last time. Whoops. John's given us a wonky shape, but that's okay because we've been finding the area of wonky shapes like this for a long time, haven't we? Okay. Volume equals area of the base times the height. That's my abbreviation version. The area of the base. All right, how are we going to find that? Well, we're going to have to divide it into 2, aren't we? Triangle. Let's do the rectangle first. I draw a picture of a rectangle. I write the formula, length times width. That would be 4 times 6. 4 is that much. 6 is that much, so that's what I want. And that gives me 24. Now I need to do the triangle. That is base times height divided by 2. The base of this, it's not 10. We have to do some subtracting, right? The base is 10 minus 4, that's 6, times the height of the triangle, not the height of our three-dimensional object. We're not talking about that yet. We're just talking about the height of this triangle. That is 6, right? It matches there. And then we divide it by 2. And that is, I'll cancel those. 6 times 3 is 18. Okay. Notice I haven't written any units on here yet. That's okay. We'll write the units on the answer. We don't have to keep writing it over and over. All right, so if I add together this and this, that's these two numbers, that's 1242. This is what we call the area of the base, right? It's that. And again, John was clever. He's had you practicing this for weeks, hasn't he? Now he's just adding this one more step. We multiply it by the height. And the height we can find, usually the height is written in the words. The information you need to find the area of the base is usually written on the map of the base. But the height of the three-dimensional object, we have to go back in and read. 6 feet tall. There it is. So the height of the object is 6. And now all we have to do is happily multiply. 6 times 2 is 12. I'll be quiet. You can multiply that yourself. And then we put a unit on it in the end. Remember, volume is always three-dimensional. And that's the right answer. This was the right answer, too. Here, I'll let you finish your calculation. All right, we're going to be doing volume problems for a long time. We're going to be finding the volume of objects that don't just have straight sides like this, but bases that are round. So that means we get to use all of our great circle problems, right? Now let me just show, or circle formulas rather. In the practice, here's a nice simple shape. So the base of this, you know, is going to be a rectangle, right? Just imagine picking it up and looking at the bottom. This one, when you pick it up and look at the bottom, it's fairly complicated, right? It's long and skinny. I wonder what's in this. A book that's open to the best page, and somebody built a box to hold the book open. Maybe. But you can do this, right? And then same for this one. Look, this is a weird one with a wonky triangle, just like the one we just did, right? Where it's straight on this side, but it's triangular there. You know how to do that because we've been practicing. All right, that's lesson 45. Have fun with that, you guys. Good luck. Enjoy.